Okay, thank you very much. So I'm Dr. Mike Garratt, based at the University of Reading. Today I'm going to be talking about the importance of pollinator diversity for crop production. But I will say this isn't a statement of fact, it's more of a kind of question that needs to be answered. So I'm going to discuss whether we think pollinator diversity is in fact important for crop production. So I won't... actually, Nicola's talk has put this into some nice context. He's given us some idea of the real value of animal pollinators or insect pollinators to crop production. So estimates varying from between, 200 to 600 billion per annum. So clearly they're important, and clearly they're providing a really important ecosystem service. And ecologically speaking, there's a general consensus that diverse biological communities provide more ecosystem services. And this is particularly true if you have greater trait diversity or functional diversity within a biological community. So in general, there's a positive relationship between diversity and function. But is this true for crop pollination? Perhaps it is, perhaps it isn't. It's a rather specific service that we're looking for. We're looking for movement of pollen between anthers and stigmas on crop flowers. So how important is diversity? And if it is important, why do we care? Well, I think it is an important question to address. For example, it will give us an indication of the potential consequences of pollinator decline or changes in pollinator communities for crop production. And it could perhaps help inform management strategies for ensuring stable crop pollination in the future. So there is evidence out there that suggests diverse pollinator communities improve the level of crop pollination and therefore crop production. For example, in pumpkins, at sites with a high species richness, we find better seed set in pumpkins. In another study on apple orchards in the US, we find that, again, as species richness goes up, so does seed set in apples. And we know seed set's important for apple quality and apple yield. And in a large-scale review done by Lucas Garibaldi, he reviewed a lot of data sets which had data on visitation to crop flowers and subsequent seed set, and he found this general relationship that species richness is positively correlated with fruit set. So this suggests that perhaps some level of diversity is important. In another study that we were involved in as well, and was led by David Klein, and this was another large-scale meta-analysis using 90 data sets on crop flower visitors from across the world, all sorts of different crops, all sorts of different regions. And actually, the study sort of concluded that the vast majority of crop pollination is actually carried out by relatively few species. Looking at the data sets, the conclusion was that actually 80% of crop pollination is carried out by 2% of bee species. And this was a study that showed that dominant crop pollinators, i.e. those that contribute more than 5% of visits to crop flowers, were only a small proportion of the total species pool of bees in any region. So this perhaps suggests that high levels of diversity, actually most of the crop pollination is carried out by a few important, probably generalist species. We've done some research ourselves at Reading University. Recently we completed a project, an Insect Pollinators Initiative project, and we were trying to understand the contribution and value of insect pollinators to crop production in the UK. So we carried out work on a number of insect-pollinated crops, strawberries, oilseed rape or canola, field beans and apples, and we carried out field surveys in these crops to try and understand which pollinators were visiting crop flowers. And we also built some flight cages at the University of Reading and University of Leeds. And these were great because they enabled us to manipulate our flowering crops and our pollinators and start asking questions about which pollinator species might be the most effective at pollinating certain crops. So in our flight cages we worked with 4 different bee species, each, I guess, representing a potential pollinator taxa. So we had a mason bee, Osmia bicornis, Epicerphus ultiatus, a hoverfly, honeybees as well, and Bombus terrestris, probably the most common bumblebee we find in the UK. So what do we find from our research then? Well, this shows some data from bean fields in the UK. Now, beans are an important crop. They're part of the arable rotation. in arable systems in the UK. And we did a lot of surveys of a lot of bean fields and found that the vast majority of visitors were bumblebees. If you consider the morphology of a bean flower, this isn't surprising. But it was actually just 3 or 4 bumblebee species. Some of our most common species were by far the most common visitors. So this would suggest that there's not a particularly diverse pollinator community that's providing pollination to beans. And then when we looked at the effectiveness or efficiency of some different pollinator species in our flight cages on beans, we looked at pod set following visitation by these different species. And we found that our bumblebee and the mason bee were actually the most effective, more so than honeybees and hoverflies as pollinators of beans. But we don't actually find any of these mason bees, or very few, visiting bean flowers in the field. It's actually the bumblebees, as I've said. So if you start combining the fact that bumblebees are our most effective pollinator and our most abundant pollinator, clearly this polarises the pollinator community even further into those that are providing the service and those that aren't. And it's not many species that are servicing beans as a crop. But if we consider a different crop, so this is data for oilseed rape or canola, and here we saw a much more diverse pollinator community visiting oilseed rape flowers. We had our bumblebees, honeybees, a lot of different hoverfly species, lots of solitary bee species, as well as other diptera and beetles. And this actually varied in space, so there were significant differences between field sites, and varied in time. There were significant differences between our survey rounds. So clearly it's a more diverse pollinator community that's visiting oilseed rape flowers. But we also had oilseed rape crops in our flight cages as well, and we compared the pollination effectiveness of some different species on our oilseed. It was the same species again, and we looked at seed set in oilseed, and we found that actually in comparison to when we excluded pollinators entirely, so the pale grey bar on the right, actually all 4 of the species we tested, despite being taxonomically quite different from each other, were all effective pollinators of oilseed rape and significantly increased seed set. Hoverflies less so than our other 3 species, but they can all effectively pollinate oilseed rape, and we find examples of these taxa in the field visiting flowers. So it suggests that there's a much more diverse pollinator community in oilseeds, certainly in comparison to field beans. But there is other compelling evidence suggesting that diverse pollinator communities are beneficial in improving crop production and pollination service. In some research done by Claire Britton and colleagues, she concluded that biodiversity helps buffer pollination from changes in environmental conditions. And the example of this was from her work on almond orchards in California. And she had orchards where the pollinator community was relatively diverse and relatively simple. At some sites there were only honeybees available and visiting almond flowers, but at other sites there were other species as well. And in suboptimal conditions, in this case high wind conditions, at sites where you had only honeybees visiting flowers, they weren't flying in these suboptimal conditions, and so there was no visitation, and therefore there can be no pollination as well in those conditions. But at other sites where there was a more diverse community that contained pollinators from different functional groups, you still get visitation in suboptimal conditions, and therefore you still get pollination and crop production. Another example of how diverse flower visiting communities might support crop pollination and crop production comes from work by Nacho Bartomeu, again looking at apples in the US, and they used a 46-year data set to look at apple flowering and emergence of different apple pollinators. And their conclusion was that with a diverse pollinator community, you can ensure that you're more likely to have pollinators that are actually active when apples might be in flower, whatever conditions might affect the timing of apple flowering. So it provides some insurance to short-term or long-term climate changes. But it would be important to consider the relative effectiveness of each of these pollinator taxa for apples, and whether some groups could perhaps take up the slack of pollination service in the absence of some other species if they become asynchronous with apple flowering. So this consideration of how effective they are as pollinators is important. And this was a question asked by Lucas in his meta-analysis, and he concluded that actually trait matching of flower visitors with a crop predicts pollination service or fruit set in this case better than just general trait diversity in the pollinator community. So I guess these graphs provide an example of this, So you've got crops which have more accessible nectar, such as this, the one on the left here with marked in orange. And he found that accessible flowers and accessible crops, better service was provided by a pollinator community that contained larger individuals within that pollinator community. If we consider a different crop, a different flowering crop, where actually the floral resource, nectar in this case, is more inaccessible, such as the blue flower on the right, then actually the pollinator community, if it's made up of individuals, species within that community that have longer mouthparts, so they're adapted to accessing this nectar, then you get better pollination service. So I guess it's kind of obvious, really. But I think what it does highlight is that it's not just general diversity you're looking for. Actually, this would point to being able to target pollinator management to those pollinator species that are particularly effective at pollinating those crops. So as a brief conclusion then, clearly some species are contributing more to crop pollination and crop production than others. And effectiveness and pollinators with appropriate traits for pollinating those crops are clearly important. And perhaps this helps target management of pollination services for improved production. So you'll get better return on your investment in managing pollinators, investing in managing pollinators in terms of returns to improved crop pollination. But of course, we can't ignore functional diversity in the system and the importance of pollinator diversity to ensure effective and stable pollination in space. So if we think about the two crop examples I gave, oilseed and beans, these crops are actually grown in the same landscape at the same time. So clearly you need pollinator communities that are able to provide services to both. And of course, through time, protecting against climate change, a diverse pollinator community will provide, at some level, will provide retained service and stable pollination service through time. And environmental variability, we've seen an example where pollination services is improved in the face of environmental variability. So it's this idea that sort of led us to be encouraged by the media team at Reading to produce this infographic. We're based in the UK, so we've chosen football as our example, but I guess you could use American football as an example. But they wanted 11 of the top pollinators. They wanted us to name 11 of the top pollinators providing pollination service to crops in the UK. So we looked back at our data sets from the number of crops that we've worked on. And we identified 11 species, which are perhaps the top pollinators, and maybe we've done a good job, I don't know, but we know these are all really important pollinators. But then they wanted a subbench of pollinators that could step in if we needed them to retain pollination services in the face of environmental or landscape change. So we picked a subbench of super sub bees that might be able to provide this service, and we base this on a number of factors. For example, Andrena cinerarea and Bombus hypnorum are actually historically quite not that abundant in the UK, but their abundance is increasing significantly now. So perhaps these guys are going to step in and start carrying out a large proportion of crop pollination. We've got some rarer species there as well. Bombus ruderantis is a very rare species, but we've seen it visiting bean flowers. So potentially, if the abundance of this species changes, then they may be providing more of a service to crop production. And finally, we looked at some of the pollinators that might be important are pollinating crops on mainland Europe, crops like sunflowers. Potentially in the future we might be growing these crops in the UK. We need to retain these species within the flower visiting community in reasonable abundances in order to pollinate these crops in the future. So I'd just like to finish by acknowledging particularly Desio and Anna for inviting me to speak at this symposium. I'd like to thank the researchers whose studies I've used as examples in this presentation, and of course the team at Reading who helped carry out a lot of this research. Thank you very much.